This is Unit 6, Chemical Bonding, Lesson 2, Bond Polarity. How are bonds affected by electronegativity differences? The objectives for this lesson: I can determine how strongly an atom of an element attracts electrons in a chemical bond using electronegativity values from Table S. And I can determine the degree of polarity in a bond based upon the electronegativity difference between two bonded atoms. So do now. So, bond polarity. Just like Earth has two poles, the north and the south, magnets also have two poles, and bonds may also have two poles, which we call a dipole, depending upon their electronegativities. So, the types of covalent bonds include nonpolar covalent bonds, where we have an equal sharing of electrons. Therefore, the electronegativity difference, or E and D, between the atoms is between 0 and zero point 0.4. This is usually between identical atoms. So, for example, the two atoms of hydrogen are the same. The electronegativity of hydrogen is 2.2, and the electronegativity of hydrogen is 2.2. If I subtract those, the electronegativity difference, I get an electronegativity difference of 0. These values came from Table S. Polar covalent bonds have an unequal sharing of electrons. Their E and D is between zero point 0.5 and 1.7. We can have higher than 1.7, so it's not an exact number, it's just an area. One atom is slightly negative and one atom is slightly positive. So this is what we call a dipole. It has two poles, a positive and a negative. So for example, in hydrogen, the hydrogen has less electrons, therefore it's slightly positive. Because the fluorine has a higher electronegativity, therefore it pulls those electrons towards it, causing a dipole. So if we have a tug of war, we can imagine this. Two elements of the same thing are pulling equally, therefore there's no imbalance. However, fluorine over here has a higher pull than hydrogen, therefore we have an imbalance in our tug of war. Comparing ionic and covalent bonds, a nonpolar covalent bond has sharing. This blue circle represents the electron cloud. A polar bond, polar covalent, has one side partially negative and the other side partially negative. And ionic bonds have no sharing of electrons. That involves the transfer. Therefore, we have charged particles, a positive particle and a negative particle. So how do we determine the type of bond? This is really important. If I have a metal and a nonmetal, it's an ionic bond. If I have two nonmetals together, it's a covalent bond. To determine if it's a nonpolar covalent bond or a polar covalent bond, I will take the electronegativity difference. If the electronegativity difference is less than or equal to 0.4, it's nonpolar. If the electronegativity difference is greater than 0.4, it's a polar covalent bond. So elements in an ionic bond are usually have an E and D value greater than 1.7. For example, sodium chloride has an E and D of 2.3. We get those values from Table S. Over here, this is the electronegativity. So if I were to take 0.9 and subtract it from chlorine, which is 3.2, I'll get that difference of 2.3. So to summarize bond types using the electronegativity difference, I like to put it on this number line, so copy this number line down into your notes. Nonpolar goes from 0 to 0.4 in our covalent range, and polar covalent goes from 0.4, greater than 0.4, to about 1.7 to 2. So notice this is a range, it's not an exact value. Ionic bonds are typically greater than 1.7 or 2. So for an example, is this ionic, polar, or nonpolar? The first thing you're going to look for is if there are metals and nonmetals. Sodium and sulfur has a metal and a nonmetal, therefore this is ionic. Carbon and bromine are both nonmetals, therefore this is covalent. Same with carbon and carbon, so it's covalent. Hydrogen and oxygen are both nonmetals, therefore this is covalent. Fluorine and fluorine, they're both nonmetals, therefore it's covalent. And potassium and oxygen, potassium is a metal and oxygen is a nonmetal, therefore it's ionic. Now to determine if we have a polar or a nonpolar covalent bond, we have to refer to our reference table S. And we're going to look up the electronegativity differences on that reference table S. So carbon, we're going to look on table S and find that carbon has an electronegativity of 2.6, and bromine has an electronegativity of 3.0. Therefore, our difference is equal to 0.4, so this would be nonpolar. Carbon is 2.6 minus 2.6, which equals 0. Therefore, this is nonpolar. Hydrogen is 2.2, and oxygen is 3.4. Therefore, our difference is equal to 1.2. Therefore, this is polar. Fluorine is 4.0, and fluorine is 4.0. Therefore, 0. We have nonpolar. So NP is nonpolar, polar, nonpolar, nonpolar. So check your understanding. See if you understand. And you should be able to say that you can determine how strongly an atom of an element attracts electrons in a chemical bond using electronegativity values from table S. And you can determine the degree of polarity in a bond based upon the electronegativity difference between two bonded atoms.